The biggest shipping loss to date occurred in the form of MOL Comfort in 2013. The MOL Comfort was caught in bad weather 200 miles off the coast of Yemen. Around dawn, it cracked in the middle and broke in two parts. But MOL Comfort was not a unique case. There have been many such cases of ships breaking from the middle. But why does it happen? When a beam is loaded, it will either bend or flex, which means one part will be under compression and the other will be in tension. When a ship's hull girder is designed, the designers analyze the structure as a beam. But this beam is different from those used by civil engineers, as ships carry unpredictably variable loads. The buoyancy on the hull is never predictable, as the sea experiences waves. The buoyancy on the ship varies periodically along the ship's length. Also, ships are not always in the same cargo loading conditions. Where they may ply one voyage in fully loaded state, the ship may not have cargo but be induced to ballast loading conditions in the return voyage. Hence, a vessel should be designed keeping in mind the uncertainty of the loads. Unlike civil structures, a ship structure, a hull girder, is always supported by an elastic foundation, which here is the sea surface. The direction of buoyancy on the girder is upwards, and its longitudinal distribution depends upon the longitudinal distribution of the ship's underwater volume. This means there is more buoyancy at the midship region than at the fore and aft ends. This leads us to a buoyancy distribution curve which looks something like this. There is a weight factor too that contributes to the load on the girder. It is the weight that acts onto the hull girder and comprises individual weights of hull steel, machinery, outfit, cargo, fuel oil, lube oil, fresh water, ballast and non-fuel cargo. Depending upon the longitudinal distribution of these weights and their magnitudes, we obtain the longitudinal distribution of the load on the girder, which is referred as the weight curve. When we superimpose both the graphs and subtract the magnitudes of weight from the buoyancy at every point along the length to obtain the longitudinal distribution of total load on the girder. The load curve is subject to change depending on the various loading conditions of the ship. This load curve holds the utmost importance in the longitudinal strength aspect. This very diagram can answer the questions we asked in the beginning. Now that the shear force on any transverse section of the hull girder is zero at the aft end, fore end and midships, so the failure due to shearing is the least concern in these regions. The bending moment is always maximum at the midship. Due to this effect, the bending stress always reaches a maximum at the midship region of any ship, irrespective of its loading conditions. A ship usually breaks if it's involved in an accident leading to structural failure and water ingress. This increases the load on the ship's structure and the bending stress, which is already high in the middle. Grounding also results in midship cracks or split-offs. This is due to unwanted load distribution along the hull, which leads to hogging or sagging, which are nothing but modes of bending of the hull girder. And it is the bending moment at the midships that had already exceeded the strength of the hull material and eventually led to the failure. A flawed ship design and poor material usage can also lead to a ship splitting in half when loaded with cargo, as suspected in the case of MOL Comfort. Hence, the bending stresses should always be kept in check. The chief officer, primarily in charge of the ship's stability, must ensure that the stresses are within the permissible limit. The ballast and cargo should be planned and loaded accordingly. For this, loading manuals are provided, which are a guide to loading the ship by the design standards, which are nothing but inferences to these different conditions of weight distributions. Do you know which is the strongest part of the ship? Let us know in the comments. And for more such information, follow Marine Insight.